Okay, so we are continuing with browsing through shaders, and I believe the next guy is the Lumas guy, or no, actually before it is the Falloff shader, which is really quite understandable. Let me apply that material. Let's take a look at the settings, and really without getting too technical, to explain this is this shader calculates this gradient based on the vector you define here and the surface normals. I hope this makes sense. Easiest way to understand this to play a bit with the settings. So if I just increase this direction on this value for just 1, you will see a change happening. And you can play with those values and you will have a feedback in viewport. Okay? It's really easy to understand when you play with it. Consider it these direction options as a rotation options from where this gradient will start and how it will behave. And naturally you can change colorization or even use 2 little gizmos, 2 little colors with gradient, or even 1000 colors if you prefer it that way. Let's clear that up, and the next guy is really interesting, and there are some tricks regarding that shader. So it's a Lumas shader. Lumas is a faking shader. It fakes specular highlights. So let me do a quick render and I will show you what I mean. And the biggest problem with a Lumas shader, if the type of the light is set to area, it will have problems with displaying specular highlights. But it works if this anisotropy mode is enabled. So if I change my light type to say something like Omni, you will see that specular highlight. To expand on that a bit more, let me color this. This first specular is the tightest and the smallest one, and it's the most brightest in intensity. The second one, you can change the color, and often the picture says 1000 words and you will see the result here. So let's say this is a medium one, and the last but not the least is, you can color it something like orange, and it's the most widest and the most softest. So if I change this to area light, you will see that there are problems here. It doesn't work when type is set to area, only if this anisotropy is enabled. And this option is extremely useful for mimicking brushed surfaces like polished metal or something like that. Let me show you that also. You will see something happening. So these speculars were elongated, so they are anisotropic. I believe that's the correct pronunciation. And the most understandable effect is this one under planar. And you will get what I mean. So you can imagine this on some material that is metallic and has those small scratches, and those speculars elongate along the surface. Really useful shader. So let me clear that up. I just want to say I'm running really briefly over those shaders. So if I would do every shader in depth, that would take a really considerable amount of time, and later you will see some of those shaders applied into meaningful way. And these procedural shaders can be a little bit difficult to grasp, but once you understand them, you will be rewarded and you will be able to create magnificently great surfaces. So let's go with our next guy. The next guy is normal direction. And if you go inside normal direction shader, we will see 2 colors options. So let me change to something a little bit more friendly. For example, something like this, violet and orange. And you can see instantly that our object rendered completely orange. And this shader looks at the surface normal, the orientation of the surface normal. So let me demonstrate that. And currently all the surface normals are pointing outwards. And you can say that because those faces are colored with some sort of orangey tint. And if we select the loop of this faces and invert the normals by UR, which is inverse normals, they will get blue. So it means they are pointing the other direction. So you can actually see the difference. The blues are pointing inwards and the yellow ones, sorry, the orange ones are pointing outwards. And watch what happens when I do a small render. Now those that are pointing inwards take this color. This actually doesn't seem like it can do much, but you can actually create clip maps in the alpha channel. So you can create transparent areas and non-transparent areas in alpha channel with that shader based on the polygon selections, which can be really handy sometimes. Let's turn off that render and clear that and cover another guy, which is this pixel guy, which is really simple. I'll just, you see, currently I want all my normals to point in the outwards direction. So sometimes you will get those blue faces scattered on the model, and the easiest way to align them properly is to hit UA, which will align normals, that will average normals. So now it averaged according to the number of these orange faces. If the situation was opposite, it will calculate to blue faces. Sounds really simple, isn't it? So it always calculates based on the higher number of ones that are pointing outwards or inwards. Hope that makes sense. So let's cover our pixel shader, which is really simple. Simply load some sort of image here. We can use the image we also used, and it will actually pixelate that, and you can set the number of tiles, for example 100 with 100, and you will get a much more better result. So you can animate these values and create those nice effects from where you create a picture from blocky shape or something like that. Okay, so let's proceed with our next lesson. We will cover some more shaders.